IU Matters, Artificial Intelligence, is a co-production of Indiana University Office of the Vice Provost for Research, Indiana University Media School, and WTIU.
It's everywhere you look and even places you can't see it. Artificial intelligence in your everyday life. Whether you're asking for directions, looking for a new book, or deciding which movie to watch, it anticipates your questions, likes, and choices. AI can help senior citizens and musicians. It can diagnose illness, analyzing vast amounts of data in an instant. Coming up, AI at IU, how Indiana University researchers are front and center in the promise and perils of artificial intelligence. Next on IU Matters. Hello, and welcome to IU Matters. I'm Ann Ryder. It's the new frontier, artificial intelligence in our everyday lives, the weather forecast, directions, and soon, perhaps, getting where we're going with a driverless ride. Advances in the field of artificial intelligence bring us images like these, robot dogs that approach a door, maneuver it open, and move smoothly right into the next room. We already rely on personal assistants like Siri, Google, and Alexa. With a simple voice command, you get instant answers that anticipate your likes and recommendations on where to dine or shop. But some say AI is at a turning point in which humans need to weigh the promise and the perils. Tesla and SpaceX founder Elon Musk is one who worries about AI going rogue. Well, we have assembled a panel of experts who are doing important AI research right here at Indiana University, and we welcome them to IU Matters. David Crandall is an associate professor in the IU School of Informatics, Computing, and Engineering, and he's the director of the IU Computer Vision Lab. Associate Professor Selma Shabanovich works in the Informatics School, and she directs a lab right here on campus, set up like a house, which studies robots in everyday use and how they interact with humans. And Christopher Raphael is a professor who heads the music informatics program right here at IU. That's right, robot musicians. Well, sort of. Thank you all for joining us today. And David, let me start with you. So first I want to ask you about this lab and the kind of things that you do there.
Sure. So I work generally in computer vision, which is sort of the area of computer science that tries to teach computers to see the way that people can see. You know, when you look at a photo, or I look at a photo, or I look at a video, or I walk into a new place, I look around me, I identify faces, I notice who is in the place, I notice what they're doing, I notice what kind of place it is, all these kinds of things. These are really, really hard tasks to get a computer to be able to do, and we're trying to work on teaching them to do it.
We have a little video that we took at your lab, and it looks like people playing games, playing Jenga, and explain to us first what we're seeing here. This is a little different.
Sure. This is an example where we're taking video of a scene from multiple different cameras, and we're trying to do something that seems really easy to you and me. We're trying to figure out which person in each camera corresponds to the same person in another camera. Again, that's really easy for us to do. I can say, oh, there's a fellow in black, and he's probably the same fellow that's in black in the other camera. And yet, this kind of subjective comparison sort of thing is really hard to teach a computer how to do, and so this is one of the things we're working on.
We hear the words machine learning and machine vision. What's the difference between those two?
So machine learning is a broad area that tries to get computers to be able to learn sort of in the way that humans can learn about any sort of thing, about seeing, about hearing, about reasoning about the future, predicting the future, all of these sorts of things. Machine vision specifically is trying to get computers to be able to see, to perceive the world through cameras.
All right. Let's move on for a second to Selma Shabanovich. She's an associate professor in the School of Informatics, and your research focuses on the interaction between humans and robots. You have something called R House with an R.
Yes.
So it's set up like a little house, right?
It is. It's actually in a house. So one of the things that we're interested in is this field of human-robot interaction and social robotics. And this involves both the design of robots that can interact with people in different social ways, so they can read social cues like your gaze or gestures, and they can also produce some of these cues, and they're meant to take kind of part in human everyday life as some kind of social actor.
So almost human-like qualities.
Sometimes
yeah.
they can be human-like, but humans are actually known for interacting socially with lots of different things, from humans to animals to even objects. So the kinds of robots we look at span a broad range of these kinds of morphologies.
And quickly, we may come back to him, but introduce us to Pero.
Oh, sure. Okay. So this is a robot we have worked with for a very long time. I met Paro when I was a graduate student, and he was designed by Dr. Takanori Shibata in Japan.
Oh.
And I worked in his lab for a while as a grad student. And so Paro, as an example of a social robot, so you can see it can tell when I'm touching
Oh,
it.
wow.
It actually has sensors in its whiskers. It can sense light. It can also orient towards sound. And so one of the things that we're looking at with Paro is how do people perceive and respond to Paro. We often use it with older adults. We've used it in a nursing home. We've also put it in people's homes with older adults with depression. And right now we're doing a study in an intergenerational daycare where we're trying to figure out if Paro can help kids and older adults interact more with each other.
So trying to use robots for social good, in a sense. That's part of what you study.
That is the hope.
Yeah.
So not Terminator, but Paro.
Not Terminator. We're glad to hear that.
Unbelievably cute.
I'm
going to turn it up.
I know
It's
you,
gonna
you
go
asked I'm putting the cart before the horse, but you asked an interesting question earlier. Does this make us the robots?
Well, sure, we seem to have these reflexive responses.
Yeah.
We hear the cute noises and we go, ah, and we wonder, do we have to do this? Do we really choose to control our actions, or we just respond like robots do?
This is Chris Raphael, a musician and professor of informatics, teaching computers how to read music. So how have you brought music and informatics together?
Well, the focus of my research is about building tools for musicians. Tools that would allow a musician to play inside an ensemble that follows them and listens to them and learns from them. Or tools that help a musician understand what they're doing, giving feedback, identify things that may not be correct. Or also things that explore the use of notation, making digital music stands so these will follow a player, turn pages, help a person to interpret what they're doing.
But at this point, we don't have a physical robot the way I might think of a robot, almost like the dog that went through the door. What does it look like, correct?
Well, it's just a computer. To me, a robot is something that senses its environment and plans the future and then takes action, whether or not they're moving parts. Mostly people think about things from Lost in Space, but this is not what I think of for a robot.
Is it tough to teach a robot how to read music?
Yes, it is. The thing about music notation, it's sort of accumulated over a couple centuries of unconstrained use. The only thing people had to do was make the human at the other end understand what they were trying to say. So for every rule, there's an exception.
Are we looking for collaboration then between the humans and the robots when it comes to music?
Well, in terms of accompaniment, yeah, it is about collaboration. It's about giving a person the feeling of playing in a full ensemble, of controlling and leading a performance, making those magical things that happen when we play music.
Well, let's open it up for the round table. And this is an impossibly broad question, but what is it that we can do at this point that robots cannot? And what can they do that we can't? David, you want to start?
Sure. Well, from sort of the computer vision point of view, computers are really good at precise, fast calculations, right? And they're really good at storing huge amounts of data. What they're not so good at is sort of making subjective comparisons between things. So, for example, if I show an image to a computer, I could have a database of 1 trillion images, and it could instantly tell me whether that photo is in that database. But what it can't do is say, oh, this photo looks a lot like this photo over here. It isn't the same, but it looks a lot like it. Whereas, if you think about what I can do, you could show me a picture. I just had this experience the other day where I smelled a smell that I hadn't smelled in a long time, and it smelled like something else, and instantly I had a flashback to this place, even though everything else was about it was different. So I think that's kind of the difference. Computers really excel where precise, fast calculations on big data is what matters, and we really excel in places where these subjective kind of decisions matter.
Do the other two of you agree with this?
Well, the really interesting part of the question for me is what the robot or the computer can't do.
Yes.
In some sense, that's what we aim to solve here. We don't know the answer to that. We want to push the limits of what computers can do. I mean, at some level, the computer will never create in the sense that we think of. It's always doing what we tell them to do. But that may not be the point. I mean, in so many important contexts, we want to give the impression to the human that there's been some sort of creation. And if we can accomplish that, we will have done what we need to do.
Selma, your view on this?
I think another thing that we come across a lot is that robots are very good at doing things, for example, again and again in similar contexts, but they don't deal very well with unpredictable environments and kind of going from one context to another and figuring out how to kind of apply the rules from one to the other. So in terms of having machines in everyday life, that's very important. In terms of social interaction, you know, how do you read the same social cue as a wink? You know, kind of, hey, we're sharing a secret, or I just have a tick and something stuck in my eye. So we're not nearly there in terms of getting robots to understand that.
And right here we are watching a robot try to sort food, is that correct? Even though
Yes.
it's not real food.
Yes, so the idea of this study, we're interested in group human-robot interaction. And so here we're studying how people interact with one or two robots sometimes to see if having multiple robots interacting with them is actually a more threatening situation. And if it is a more threatening situation, how do you actually make it less threatening so that people can collaborate more easily rather than being intimidated in that context?
And robots in everyday life, I mean, there are some who believe we will all be riding in driverless cars in the next 5 years, and we've seen some of the perils of that. There was the accident in Tempe. Woman behind the wheel did not have her hands on the wheel and hit a bicyclist and killed the bicyclist. So thoughts about things like, you know, driverless cars and whether you believe they're here to stay or will be here to stay.
I sure think they'll be here to stay. And of course, some things like what you described are going to happen in the process of getting to where we need to go. But the way we have to look about it is in terms of the big picture. I mean, there are an awful lot of accidents that are caused by human error, human negligence. So the question is, do we have less if we do it this way?
Mm-hmm. Also, did you have something you wanted to add to that?
I also wanted to add that I think one of the things that the driverless cars bring out, which I think is true of most of these robotic technologies, is that it's not just about what's happening with that particular technology or even the direct interaction with the human, but we also obviously need kind of societal mechanisms for figuring out how to introduce these. And, you know, there are kind of legal issues, economic issues, lots of different concerns that sometimes don't really come out necessarily when we're worrying about, you know, the technoglasses, just getting the technology to do what we'd like it to do.
There's an older man riding around in a driverless car right now. And of course, all this has vast implications on jobs. Will robots replace us in the workforce? Thoughts?
I think we already have robots in the workforce in certain spaces, and I'm sure that they're going to be replacing certain kinds of things, but I don't think robots will replace us fully in any context. So one of the things that we, for example, noticed in using robots in elder care is that we think of robots as autonomous, but in order to actually have the robot work in the way and have the kinds of effects we would like it to have, there's a lot of labor that happens from the side of the nurses, from the side of other people in the environment, the family, that we can also take into account. So I think we also need to consider how to actually support the people who are working with the robot.
So what scares you, each of you? Is there anything that brings you fear about this kind of technology?
So I would say for me personally, I'm not worried about like the robots gaining consciousness and taking over. I don't think that's the main risk. I think the main risk is that we start we choose to start trusting AI technology too much without really understanding what it is. And this can be subtle things. We're seeing this discussion about what happened during the last election cycle on Facebook, for instance, where it wasn't like machines decided to promote false information, but it seems like the algorithms that were designed for something else were used to carry that out. And so that's what I'm worried about. I'm worried about AI technology that we trust for things like making admissions decisions to school, or making job hiring decisions, or things like that. And sure, they're very good at this task statistically, and that they choose who might be successful in school. But we don't really understand what kind of biases or stereotypes or other sorts of things that they're using, and we're trusting those algorithms in a way that I just worry a little bit about.
How about you, Chris?
Yeah, I worry about people being displaced in the workforce. I think this is something that will happen to some extent, but I think the way to look at there's this burgeoning area of human-in-the-loop computing. There are just all of these wonderful opportunities for work environments that blend both what the computer does well and the human does well. And I think this is going to be something that will be very important and powerful in the future, and will greatly increase what people can accomplish.
Well, for instance, a child going across a crosswalk, a human, that would immediately trigger, warning signals. Can computers be taught that kind of thing to react to that?
They could in some way, shape, or form. But the
you would have
question
to
is,
tell it, yeah.
Right, you have to tell it, and perhaps it could learn to some degree, but how much would you be willing to trust a computer to take your child across the crosswalk, or to take your child on a ride, right? I would not quite trust a computer to take my child, although I wouldn't trust an individual Uber driver either. I would still be in the car, right? So.
So when Elon Musk sounded the alarm and said, we are really at a turning point in the artificial intelligence, and I'm not sure he was really promoting regulation, but caution. It says there really are ethical issues around this. Do you agree?
Yeah, absolutely.
Yes.
There are. I mean, the self-driving cars are one of the most interesting examples of the ethical issues. I suppose one can look at it in terms of the greatest good for the greatest number, and I'm sure that that's a reasonable way to look at it. But I mean, if my car is going to decide that it's going to sacrifice my life in exchange for 10 other innocent people, I suppose I'm not so happy about that possibility.
Right.
But it's really interesting somehow, in the split second, if you and I are driving and we're about to have an accident, we're going to make some decision that's based on something, and it's going to be partially just random because we're only given a split second to think about it. And somehow I'm more comfortable with that than with the computer actually figuring out what is the right thing to do in this situation. And it's kind of, I don't quite understand that.
Well, also because for the computer to figure out what to do, there needs to be some premeditated, in a sense, work by software engineers and others beforehand to figure out what is the appropriate thing to do, right? So you actually kind of take it outside of the usual ethical context we're used to, this split-second decision, into a much more kind of thought-through process.
Right, yeah. I'm not sure why it's okay with me that something just kind of random happens based on the decision of someone that I don't know, I don't necessarily trust, I know nothing about them, and yet having sort of an algorithm make this decision for me, yeah, it really bothers me. I can't quite figure that out yet. I think that's something we're all grappling with.
And wasn't there a test where the computers actually started, I don't want to say their own language, but it's along those lines. That's what gets creepy for a lot of people, is when they start communicating in ways that we can't understand. Can someone speak to that?
So I think that was an experiment that was done at Facebook, I think, and that was actually considered a failure. They were trying to develop AI techniques that would be able to negotiate in the way that you or I might negotiate for making a sale or something like that. And they really wanted it to learn how to conduct this in English, but it discovered that English isn't so efficient, and so it's better to just pass back little messages that only the computer could understand. Now, I say only the computer could understand. Now, the people could actually understand it. They could decode it. They could figure out what was going on there. That's how they knew what was going on. And it's no different from the way that computers already communicate all the time using binary code that you or I don't necessarily understand. So I think it wasn't really a case of the robots trying to develop their own language to overthrow us. They were just making the observation observation that it's more efficient to do something else. And so I think that particular example was overblown in the media, but it does raise interesting questions about what could happen next.
How does this change education, potentially, and the model that we have now, and how we should teach? Who wants to take that on?
Gosh, that's a great question. I can't help plugging the work that David and I are starting, trying to use the computer as a tool for teaching music. And I think sort of the most important thing to understand here, the problem of music education, the way we do music education is great, but it doesn't scale particularly well. It takes one person for one student most of the time. And the idea of having a teacher that could not just reach one, but could reach thousands of students is really compelling. And it will be, at least for the time being, less than what a human could do. But it may be enough to start the process of self-learning, which is always the main goal of education anyway.
Well, we have electronic music now, but this, what are some of the other applications in terms of robotics and music?
I was just describing
Yes.
what we were, so the idea is a computer can sense what a player is doing, where they are in the score, what notes they're playing, what fingers they're using, and one hopes all of this could be assembled to help them to learn, to point out errors that they're making, to propose tasks that are appropriate to their level, to do things that make the experience more enjoyable.
Mm-hmm. How else will this affect education?
I think the other thing that comes to my mind is the need for more and more interdisciplinarity in education, which I think we actually do a lot of in the School of Informatics, Computing, and Engineering, but also collaboration. So I think all of us, in terms of thinking through how some of these technologies can be either designed for or evaluated in different use contexts, whether it's music or elder care or educational applications, we work with others who are domain experts. And I think we're going to be seeing more of that, and teaching students how to work in those kinds of collaborative environments will be important.
One thing we're doing here at IU, which I think is really unique, is a collaboration between computer science and informatics and psychology and cognitive science to study learning in general, both in machines and humans. And the idea is, by understanding sort of the strengths and weaknesses and the mechanisms that computers can use to learn, we might better understand the way that little kids learn, and vice versa. And maybe this could give us strategies for dealing with things like autism, for instance, where kids learn differently, and maybe we can figure out how to best sort of optimize the way to optimize their outcomes.
Well, and one thing that we know that computers can do, in medicine, they can analyze vast amounts of data, not to replace the doctors and the humans, but obviously when people are getting tests run, that could be very, very helpful. So, and why is Paro a seal? Let's bring Paro back up here.
Sure.
I don't want to. Yeah, that's by design, right?
Yes.
Yeah.
So it's a seal by design. An initial the earliest design of this kind of technology by Dr. Shibata was actually a little dog, and then it was a cat. And one of the things that people noticed with the cat was that when you saw a cat, if you had experience with cats, which many of us do, you had lots of expectations, and the robots could never quite fit those. They didn't learn like cats do, they didn't change their behavior like cats do, they didn't have the diversity of the behavior like cats do. So actually having a seal, and we've seen this in some of our research, allows people to come up with a narrative of what it's doing, why it's doing it, that fits the context and fits their needs in the moment. So sometimes we've seen people interact with it as a pet. Sometimes we've seen people interact with it more as a way of kind of projecting their own emotions. So saying, you're here, are you lonely? I'm lonely too. And so because nobody knows what a seal is exactly supposed to do, but it's cute, and we all know that babies are lovable,
Yes.
It kind of promotes the effect that they would like, which is this kind of therapeutic.
Sleeping or not on?
It's not on right now,
Okay.
but I can get it on.
Paro might be anchoring our next show. I mean, we never know. Right now it just makes a few noises. But not only does Paro make cute noises, what else is it intended to do?
It's meant as a kind of substitute for pet therapy. So it's supposed to give a similar kind of psychological effect of relieving stress. And then in our work with the older adults and children in the daycare, it's also meant to try to get people to actually not just interact with the robot, but to interact with each other. So it's kind of a focal point of conversation.
We are in our final minute. Final thoughts, starting with you, David.
I think AI is exciting. I think it's really interesting how far we've come. The more I learn about it, the more impressed I am by humans, because it took us 50 years to build something close to a self-driving car. Any 16-year-old learns to drive in like a week. I think that's pretty amazing.
What do you think, Chris?
It's going to be a great ride. I mean, at some level, we have to admit that the computer can only do what you tell it, but this is way less limiting than we all thought, especially when you couple in big data. So it's going to be fun.
More promise or peril?
I think there's a lot of promise, and I always go back to the human. So I think we have a lot of decision-making potential in figuring out what these things do and how we work with them. And I think we should talk to more and more people about it. So not just experts, but people who might use these as well.
Thank you so much. Thank all of our guests for being here, and all of you. We'll see you on the next edition of IU Matters. Right.
Thanks for having us.
Yeah, thank you. This was fun. It was really fun.
IU Matters, Artificial Intelligence, is a co-production of Indiana University Office of the Vice Provost for Research, Indiana University Media School, and WTIU.